So in my previous lecture we have looked into different multiplexing techniques, and we also understood the concept of multiplexing along with its advantages and disadvantages. Now please recall our OSI ISO OSI model, which was a model of 7 layers, and now it is high time that we should kind of look, or we should explore all those layers into kind of we can say detail. So moving forward, today's agenda is about the data link layer, because the physical link layer is operating on the bits. Data link layer, which is kind of doing something we can say extra as the second layer of OSI model. So we are going to explore data link layer and its functionalities and other nuances of this in today's lecture. So this data link layer, which is kind of we can say the second layer from the bottom, it creates and disbands the communication points between network devices. And this layer is actually responsible for how the systems communicate over a network. So that 7 layer OSI model, when we talk about all the 7 layers over there, will work together and encompass the functionality ranging from the physical setup to how the apps runs on the user interface. So we can say the functionality taking from the bottommost point to the highest level. A data link layer, basically if we talk about, that sits between, being the layer 2, that sits between 1 and 2, which is the physical layer, the bottommost layer, and the network layer in the OSI model. This layer will receive and transmit the information to and from both the layers, which is physical and network, with each responsible for a different subset of information. So from the network layer, it gets the information as the packet data, logical addresses like MAC addresses, and so on and so forth. After receiving this information from the network layer, it breaks it into the data frames before decoding and then recording it into the format which physical layer can understand. So which is the format of, we can say, bit streams. So after decoding and recording it into the physical layer format, this is going to kind of transfer the whole data onto the physical layer. So the physical layer can later pass a bit stream back to the data link layer on the receiving end, which gets converted back to the packet for the network layer and then transferred we can say to the top. So the data link layer on the kind of senders end take the data from the network layer, gives it to the physical layer in the required format. At the receiving end, it takes the data from the physical layer and then kind of gives provides that data to the network layer in the required format. So basically this data link layer aims to facilitate an error-free transfer of information between these layers, so that the data can be transmitted properly between the devices. So this is, we can say, a macro level functionality of data link layer. Now this data link layer is actually having two different sublayers. One is the media access control layer, which is, we can say, or we can say media access control sublayer, which is MAC sublayer. Another one is LLC sublayer, which is logical link control. Now if we talk about detailed functionality of this data link layer, this manages the data flow between devices, particularly within the data link layer. This MAC sublayer is someone who manages the data flow between devices, so that the information does not collide on the transmission pathways. And how this is being achieved? This is being achieved by connecting MAC addresses, ensuring a clear flow of information between source and destination address. And I am sure you understand what actually a MAC address is, which is kind of the local address of your computer system or node, we can say. While the functionality of MAC sublayer is to manage the data flow between devices with the help of MAC addresses, your LLC sublayer provides the logic for data linkages, including checking for errors, identifying protocols and synchronizing frames. So, all this is the kind of we can say functionality of your LLC, which is logical link control sublayer. Now, when we looked into the functionalities of the data link layer at a whole, and just now I have given the idea of that this is the macro level we can say functionality. When we look into the micro level functionality, we have kind of different points about it. So, one is we can say framing the data, then we have controlling the data transmission flow, ensuring reliable data delivery, detecting various errors and multiplexing data streams, and the details of multiplexing we have already seen in our previous lecture. So, all these we can say are the we can call them as the benefits of the data layer, or we can call them as the kind of functionalities of the data link layer. Now, let us try to explore all these functionalities, which is framing, controlling data transmission, ensuring reliable data delivery, error detection, multiplexing in at a greater length of detail. So, framing, when we talk about this data link layer organizes the raw bits which are being kind of taken from the physical layer into structured data units, and those structured data units are called as frames. Now, it also ensures the proper synchronization between sender and receiver by adding different headers and trailers to the data. So, framing helps in identifying the beginning and the end of the data packet, and hence provides the data loss or corruption. So, basically a raw bit stream is being taken from the physical layer, it is being divided into different frames. Each and every frame is given a header and a trailer in order to have a complete identification of itself. So, this activity is actually what we call is framing. Now, when we look into framing, there can be two types of framings. One is fixed size, another one is variable size. So, as the name indicates, fixed size is having fixed size frame, variable size in which the size of the frames is could be different. But if we look into kind of how this framing is going to help, so we can have this with the help of a figure. So, here we have a data which is coming from the upper layer. Then this upper layer is actually kind of giving, or we can say the data is divided into different kind of frames, and if required some extra bits of headers and trailers are also kind of we can say being introduced. Then this when these at the kind of we can say sender, and these are the frames which are kind of received. So, at one end the data can be stuffed in order to kind of make them separate frames which are the frames sent, and at the end where the frames are received from the layers above, then they can be kind of we can say unstuffed. Those extra bytes are going to be kind of removed, and because of that unstuffing, now it is kind of is having the raw stream format, and then this is kind of being transferred onto the next layers. So, this is basically like what we can say is the kind of activity of framing, and within this headers and trailers are obviously going to be kind of introduced as and when required, depending upon whether the frame is a fixed size one or the variable sized one. Then there are some escape bits and other technicalities which go along with this framing activity. Moving forward, one of the main, kind of we can say one of the important functionality or the benefit of data link layer is error detection. So, error detection is kind of detecting the errors for which different methods can be employed. So, some we will be looking into some common methods. So, the first or the very common, or we can say naive or simple method is simple parity check. So, parity is kind of an kind of an error bit. So, this parity check involves adding an extra bit called the parity bit to a string of data bits. So, a string of data bits which is received is being kind of stuffed or added with an extra parity bit. This bit is set to make the total number of ones either even or odd. So, if we talk about the number of ones is even, that means even parity is there, and the number of ones is odd, that means odd parity is there. And when the data is received or read at the opposite end, the parity bit is checked to see if it matches the expected value even or odd. If it does not match, that means that indicates an error which may have occurred in the data transmission. But this is kind of, we can say some a very basic or very naive method of checking the error, which is having its own disadvantages or its own kind of loopholes. So, in order to understand this parity check, let us see this with the help of a figure. So, at the sender's end we have a bit stream which is 1, 000 and 11, and after computing the parity bit we are kind of adding one more bit which is 1. So, now the total number of 1 bits in the whole data stream has become kind of even, which is 4 now. Data is being transmitted, and at the receiving end, that parity bit is being computed. So, parity bit is expected to be 1 in order to make the the total number of ones as even. So, if it is even, then the data is accepted. If it is not even, then the data is rejected. But someone may raise a question here, what if kind of 2 bits are being changed, one the 2 zeros are erroneously can be changed into 2 ones, then also it will be kind of an even parity bit. So, okay, fine, that is the drawback of this parity checking, and that is why I have told you that this is one of the most basic or one of the most kind of, we can say, naive methods of error checking, which are having its own drawbacks obviously. Coming on to the next method of checking, which is checksum. The sum of data bits in checksum method, the sum of data bits is calculated and a small value which is known as checksum is appended to that data. So, now here we are not appending the parity bit, we are appending some checksum. The receiver performs the same calculation and compares the results to the transmitted checksum. If the kind of transmitted checksum is being is matched with whatever is being calculated at the receiver's end, the data is considered to be valid, and if not, we can say that kind of an error is detected. So, one is adding one parity bit in order to make the total number of ones either odd or even. Another one is the checksum method. The next one in the line is CRC, which is also a kind of error detection mechanism. CRC stands for cyclic redundancy check. So, this cyclic redundancy check is kind of, we can say, relatively a sophisticated and a complex method as compared to your checksum and the parity bit, which are kind of very simple. So, this CRC treats the data as a large polynomial and divides it by a predefined polynomial divisor. The remainder of this division is appended to the data. Again, at the receiver's end, the receiver performs the same division checks if the remainder matches the transmitted CRC. If there is a match, then an error is detected. If there is a mismatch, then that error is detected, and if there is a match, that means the data is corrected. So, all the methods which are kind of which we have seen till now, either which is the kind of parity bit or your kind of checksum or even CRC, all these are error detection mechanism. Error detection mechanism as in they are sufficient to or we can say that their task is to detect the errors. What if the error is there? So, we have detected that yes, an error is there, that error has to be kind of corrected. So, for error correction we have kind of different mechanism. So, it is not only the error detection which is kind of the job of the data link layer, it is also the error correction. And error correction involves the techniques of correction of errors that may occur during data transmission between two nodes in a network, and detection is kind of finding out that an error has occurred. In order to correct that error, we have common error correction methods. One of the most common error correction method is ARQ, which is automatic repeat request. So, this automatic repeat request uses a feedback mechanism to ensure that the data is received correctly. If an error is detected, the receiver sends a request for the sender to retransmit the data, and hence it is known as automatic repeat request. So, if you want to repeat the transmission of data, the sender is going to kind of request request for the retransmission in case of an error. So, what are these kind of common ARQ methods? So, common ARQ methods or kind of various protocols of ARQ, one is stop and wait ARQ protocol, in which the sender waits for an acknowledgement before sending the next frame. So, if the acknowledgement from the receiver is coming, then only the next frame will be sent on to the network. If it is not coming, then it needs to kind of retransmit the previous frame for which the acknowledgement has not been kind of received. So, it will wait for some time. So, the sender will wait for sender will stop the transmission, it will wait for some time to get an acknowledgement. So, if an acknowledgement is being kind of received from the receiver's end, then only it is going to kind of send the next frame, otherwise the previous frame is going to be retransmitted. This is stop and wait. Then there is one kind of protocol which is known as go back N ARQ, N as in N as number. So, the sender can send multiple frames, but if one of them is lost or maybe it is having some error, all the subsequent frames must be retransmitted, and how many frames are to be retransmitted, that is going to be kind of defined with the help of that number n. So, this is go back n. So, whenever there is an error or a lost frame, all the subsequent frames must be retransmitted, and that n is going to indicate how many frames. Then there is a selective repeat ARQ, in which only when we call it as a selective repeat, only the frames with the error or the lost frames are retransmitted, and hence this will improve the efficiency. So, it is not only, as I have told you, it is not only the error detection, but also the error correction, and in error correction in cases for the cases of error correction, we have ARQ protocols. Apart from this, flow control is also the task of your data link layer. So, when we say flow control, basically a method to manage the rate of data transmission between the two ends, which are sender and receiver, in order to prevent buffer overflow at the it could be at the sender's end or at the receiver's end, or even the congestion is to be going to be kind of we can say managed, or in order congestion is also going to be prevented. So, if the sender is slow and the receiver is fast, then also kind of bandwidth is underutilized, or if it is otherwise that the receiver is fast and the sender is slow, the slow sender will be kind of overwhelmed by so much of data congestion. So, flow control methods are kind of, we can say there are various methods of flow controls which can say stop and wait could be one of them, or there is a kind of sliding window protocol. So, we will be looking into all these methods into kind of detail in our upcoming lectures. Apart from this, we have addressing, which is also one of the most important function of the data link layer. So, when we talk about addressing, so addressing, as I have already told you, that the data link layer is being kind of divided into two sub layers, which is the MAC sub layer and the logical link control LLC sub layer. So, addressing at the data link layer is used for identifying device within the local network or the link. So, whatever we talked about at the kind of physical level or at the physical layer level or the data link layer level, we are talking about the local network. So, it uses physical, or we can say MAC addresses, to ensure that the data is delivered to the correct device. So, if we talk about MAC address, let me help you recall that it is a hardware address associated with the NIC or the network device. The MAC address is used to route the frames between devices within the same local network or between the connected networks in a point to point link. And logical addressing can also be used with MAC addressing to provide higher level services such as multiplexing, or even identifying various protocols which are Ethernet, Wi-Fi, or it could be different other protocols also. Now, with this all kind of addressing, data correction, then data detection and framing, and multiplexing, which are the functionalities taking place at the kind of data link layer, let us look into what are the limitations of data link layer. So, it lacks encryption and authentication, hence it becomes so much vulnerable to the attacks such as MAC addresses, spoofing, and even kind of eavesdropping. As I have told you that it operates within a local network or a direct point to point connection, it cannot handle routing between multiple layers, because that is going to be happen at the network layer, which is the layer 3. Again, if I am talking about the physical layer, or I am talking about the data link layer, that means I am talking about the kind of a LAN or a local network or a direct point to point connection, which is not able to handle routing across multiple networks. That is actually not the not the expectation from the data link layer. Also, it lacks encryption and authentication. Then because of this lack of encryption and authentication, it is a prime target for attackers to infiltrate a frame, such as through MAC flooding or so on and so forth. Each frame here is having a header, body, and trailer. Attacker can view any of these, and hence your data can get compromised. So, for this reason, security, we need to ensure that we need to ensure for a tight security, so which is going to be achieved through encryption. Another idea could be MAC address filtering and disabling some ports. Now, if we talk about the main switch, or sorry, the main device which is going to be used at data link layer. So, the main device here is the switch, which is used to direct the data packets between devices on a network based on their MAC addresses. What are the common protocols in data link layer? So, the common protocols in data link layer include Ethernet, which is IEEE 80.3, 802.3, then Wi-Fi, which is IEEE 802.11, triple P point to point protocol, and HDLC, which is high level data link control. So, your data link layer is going to achieve all those functionalities which we described with the help of these common protocol. So, in this lecture we looked into, we explored the data link layer functionalities into a quite, kind of, we can say, greater length of detail. Here is a list of references which is being used for the preparation of lecture. I hope you have enjoyed this one. I will see you in the next. Till then, take care. Goodbye.